So we're going to be using the focus and the directrix to write the equation of a parabola. So as you can see here, here's kind of the standard equation for a parabola in vertex form. Here's our vertex. And so that's going to be part of it. We're going to first find our vertex, plug that in, and then find out what the vertical stretch is going to be on this parabola. And I'll show you how to do that in a bit. But the first step is going to be to find our vertex. So the focus and the directrix are a line and a point such that every point on the parabola is the same distance from this line as it is from this point. So the vertex is not going to be an exception to that. The vertex is going to be the same distance from the line, the directrix of y equals 1, as it is from the focus, this point here at 2, -3. So if we want to figure out the vertex, all we have to do is think about what point is halfway in between this line and the focus. Well, this line and this point are 1, 2, 3, 4 units apart, and so half that distance is going to be 2. So right in the middle here, right here, that's where our vertex is going to be, because this is halfway in between the line, the directrix, and the focus. So let me just add that on there. So halfway in between here, well, that's going to be the point 2, -1. So as you can see, the vertex is always going to have the same x coordinate as the focus. So here's a 2 and here's a 2. So that's always going to be the same as the focus. But the y coordinate is going to be different because it's going to be halfway in between whatever this y coordinate is and whatever the directrix is. So -1 is halfway in between -3 and 1. So we found our vertex, hooray. Let's just make a note of that. So our h comma k is going to be 2, 1. Okay, now we have to figure out what p is. So, and then we can plug the p into the formula. So we have h to plug in and we have k to plug in. So let's go ahead and figure out what p is. P is going to be the distance from the focus to the vertex. So the focus is my red dot and the vertex is my green dot. So how far are these apart? Well, they're 1, 2 units apart, because -3 and -1 are 2 units apart. So my p is 2. Okay, now I just need to plug in 2 for h, -1 for k, and 2 for p, and I have my formula. So y equals 1/4 times 2, and then times x minus, and I plug in my 2, and all that's squared, and then plus a -1. Okay, so now I just need to simplify things a little bit more. And we got it. So 1/4 times 2 is going to give me 1/8. Because 4 times 2 is 8. And then if this had been a -2, then the negative and the negative would have made a positive. It's a positive 2, so it's just going to be x minus 2 squared. Okay, and now I have a positive and a -1, so a positive and negative give me a negative, so it's going to be -1. So this is the equation of my line, y equals 1/8 x minus 2 squared minus 1. Okay, let's look at another example. Okay, so for my next example, I have a focus at -3, 6 and a directrix at -4. So again, we're going to find the vertex. We're going to find halfway in between -4 and 6. So if you're ever having trouble finding what's halfway in between the y-coordinate of the focus and the directrix, then you could always just draw a little picture here and visually look and see, okay, 6 is, it's from here to here it's 6, and from here to here it's -4, so the total distance is 10. Well, so that must mean that whatever the vertex is 5 units, is half of 10 is 5 units from here and 5 units from here. So you just count down 5 units, so 6, 5, 4, 3, 2, 1, and you would see, okay, here's where my vertex would be. A way to do that mathematically is you would just add up your y-coordinate and your directrix, or sorry, subtract them. So negative, let me undo that. So you would say 6 minus -4, so I'm subtracting them to find the distance, and then divide that by 2. And then I get 6, and then this 2 negatives make a plus, so it gives me 6 plus 4 divided by 2 equals 10 over 2, which gives me 5. Okay, so I know that 5 is the distance from my focus to my vertex, because that's halfway in between my focus and my vertex. So I just go down 5. So if my directrix is below my focus, then I go down 5 to find my vertex, and if my directrix were up here above my focus, I go up 5. It just happens that in this case my directrix is down below my focus, so I'm going to go down 5 to the point, let's see, so that'd be 1, -3. So just like in the other example, the x-coordinate stays the same, so it's -3, 1. And this is where my vertex is. So my vertex, I'm going to say, is, -3, 1. And as it happens, we've actually already found our p. So by finding the distance between 6 and -4, we found p, because that's how far it is from my focus to my vertex. Because my vertex and my focus are just going to be halfway, and my vertex is just going to be halfway in between my focus and my directrix. So this is p right here, 5. Okay, so I have p, I have my h and my k. I can just go ahead and plug stuff in. So I say y, oh man, it's so hard to write this computer, but it's okay, we'll get through this. So y equals 4 times 5, and then all that times x minus a -3, and all that squared minus +1. So I'm just going to go simplify things. So here I have 1 over 4 times 5, so that gives me 1 over 20. And then I have x minus -3, so that gives me x plus 3. Well, that's squared. And then -1. Okay, so I got it. So and that all that equals y. I mean, I have the y equals over here, but I'm just going to write it again over here so I can have my complete equation of my parabola. So this is my equation of my parabola with a focus at -3, 6, and a directrix at -4. Okay, one more example. Okay, here's my last example with my focus at 0, 5 over 2, and my directrix is the line y equals 1/2. So this blue line here again. So again, I need to find my vertex and my p and plug them in. But first, before I do that, I have to figure out what's going to be the halfway in between 5 over 2 and 1/2. So even though they're fractions, let's not despair and just do what we did last time to find halfway in between. So we're going to take 5 over 2 plus, 5 over 2 minus 1/2 and divide that by 2. So, oops. 5, 2 minus 1/2 divided by 2. So this gives us 4/2 divided by 2. And 4/2 becomes 2. So we have 2/2 equals 1. So luckily enough, this halfway in between the distance that's half of from here to here, which is 1, is also going to be our p, like we saw last time. So we know our p is 1 already. Okay, so knowing that this is 1, we need to figure out what the vertex is from that. So if we go down 1 from 5/2 from my focus, that's going to be where my y-coordinate is. And we know that the x-coordinate is just going to be the same to me at 0. So what is 1, or is it, pardon me, 5/2 minus 1? Well, that's going to be 3/2. So my vertex is at 0, 3/2. So this green point here, which is halfway in between my focus and my directrix. Okay, so I know my h comma k is 0, 3/2. Okay, now I just have to plug my h over k in and my p in. So we get y equals 1/4 times 1, and then times x minus 0 squared, and then plus 3/2. So this one's going to be nice and easy to simplify, because 1/4 times 1 just gives me 1/4. So we get 1/4. Let's get my vertical stretch on this parabola. And then x minus 0, we don't need to write the minus 0. It does nothing for us. So I can just get rid of that parentheses even and write x squared, and then plus 3/2. C is the same. And that equals y. So this is my equation of my parabola.